welcome back to the second day of reviewing Trig that we had, like we said, back in Pre-Calc C, that we want to go over and refresh and highlight. We are going to give a couple shortcuts that maybe at the Pre-Calc level we don't do, because at that level we need very conceptual understanding and application. At the Calc level, we just need to be able to, I'll say, simplify and evaluate. And so we're going to be able to get a couple different shortcuts to do that, but at the end of the day, you still, it's very beneficial to know those relationships and what is happening and how you could figure it out, because the shortcut really only works for 4 angles in a whole unit circle, which we'll talk about here. Okay, so on day 1, we did a lot with special right triangles and angles and where things were. As a reminder, at a calculus level and on your AP test, everything is going to be in radians. Now, you'll notice the very first problem, I have degrees here, because Miss Marshall and I, both of our minds got to think in terms of degrees, and that's usually we find our students relate to that, but we have to then make sure conceptually we switch back to, okay, what does that mean in radians? Okay, so 330, as a reminder, 0 degrees or 0 radians starts here. So we go around, we got 90, 180, 270, and then this would be back at 36 degrees or 2 pi in radians. So if I'm at 330, I have gone all the way around, and I am a little short of my 360, specifically by 30 degrees. Okay. Now, when we are evaluating this, and so we'll talk about what we're going to evaluate in a second here, but what this picture draws is something called, so this is your angle. This 30 degrees, though, is something we call our reference angle. So reference angle. And it's used in what we're going to call our reference triangle. Now, your reference triangle is created when you take like the line of where you were, and you have to connect to the x-axis. You cannot, well, connecting to the y-axis gets all of your lengths and stuff basically backwards, because you're going the wrong way, you'd be going this way. So you always connect to your x-axis, and so this is the reference triangle with my reference angle, because this angle out here is your 300 degrees. Okay, now special right comes into play, that I have a 30 degree angle, so this is a 30, 60, 90. So that makes this, so we'll talk about sines in a second here, but the sine opposite 30 is 1. The hypotenuse is double that, and then this side is times the square root of 3. Now, because of the location, this needs to be a -1 because I went down 1. And so some of those special right values will get negative signs. Your hypotenuse, however, is always positive, because when you do the Pythagorean theorem and you square these numbers, you always get positives because you're squaring them. So that 2 will not ever be -2 for this. Okay, so then it will have some type of question. So maybe it says, what's your tangent of 330 degrees? And so you look on here and you go, all right, tangent is opposite over adjacent. My opposite is -1, and my adjacent is the square root of 3. So that would be that. Okay, so kind of some steps here of what we did. So first, I'll say draw your angle. So that was at 330. This is an angle symbol, sorry. Then you're going to draw what's called your reference, I'm going to say angle and triangle. So that's this 30 degrees in this angle. From that, it is going to be a special right. So I'll say special right. And with that, label your sides. Okay, kind of a star here. With that, be careful of, are they positive or are they negative? Because this is a graph. Like if we're at a triangle over in this third quadrant, the x and the y would be negative values to get you to that third quadrant, and then fourth would be just evaluate the trig. So evaluate trig. Okay. All right, you can see I'm running into my next example here. So 135. So I know this is 90, this is 180, so I have to be somewhere in here, opening 135 degrees. And then I do, all right, how short am I of 180? Well, I'm 45 degrees short, and I create that reference triangle. So there's step one, graph 130, sorry, that's an arrow. Draw your reference triangle and angle. Now label your sides based on your special right. Well, I know 45/45s are 1 square roots of 2. Now I go and check my positive, negative. Well, I went left, so that's a -1. I went up, so that's fine, staying positive. And then I want secant. So, got to do a little review from yesterday. Secant is the reciprocal of cosine. Cosine, so the cosine of x is adjacent over hypotenuse. So that means secant of x, sorry, is hypotenuse over adjacent. So this would be hypotenuse, square root of 2 over adjacent, which is -1. So it's negative square roots of 2. Okay. So we're going to practice this a few times in your homework. And we have a couple coming up in a couple slides as well to revisit this. All right, just some reminders then. Let's do kind of just a quick review of your 6 different trig functions. So if I want 5 pi over 6, this is a lot of fraction work, but if you check out the pi will be there because it's radians. 5/6 is just short of 1 pi. So remember, this is pi, or it's 1 over 1 pi. So you are just short. So here's your 5 pi over 6. And how short are you? You are pi over 6 short of 1, or 1 pi. Okay, and then again, my brain is very degrees oriented because that is what we learned first and for many years. So pi over 6, that is your 30 degrees. One way, if you kind of aren't sure how to do that, the pi is just there because it's radians. The 6 is what's breaking that 180, and 18 divided by 6 is 30. So that's why I knew it was 30. If you have like pi over 3, that's 180 over 3, which would be 60. If you have pi over 4, that is 180 over 4. That's not as clear, but that is 45. I'm sorry, 45 degrees for that, because you're breaking it into half, which is 90, and then half, which is 45. So that's kind of, and that will come back when we talk about the unit circle in a couple slides. Okay. All right. So back to this, actually evaluating this. So I drew my angle. I drew my reference triangle, and my reference angle got labeled. All right. So now, since I know this is 30, this side is 1, this side is the square root of 3, and this side is 2. I check my signs. That's going to go negative because I am going left. And now it wants me to evaluate a bunch of, that's a 1, of your different trig functions. So I'm going to slide down so I can see them all, maybe. There we go. All right, so sine, remember, the opposite over hypotenuse, so that's a half. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, I'm sorry, yeah, opposite over adjacent. There we go. One thing I do want to talk about is this answer is fine if you are writing it. If it is a multiple choice question, it is going to rationalize the denominator. So it's going to times top and bottom by the square root of 3. So it's going to give you negative square roots of 3 over 3. So the negative I just slid up. Square root of 3 times the square root of 3 would be square root of 3 squared, which is just 3, and then 1 times up there. So this answer is fine when you are writing it, but if it is multiple choice, it will always simplify to that. Now when we go to cosecant, I just remember these are backwards. So the cosecant goes with sine, and so I just take sine and flip it over. Secant goes with cosine, so it is -2 square roots of 3. In fractions, we generally leave the negative in the numerator because it's still, the whole fraction is negative. So that negative doesn't need to be in the denominator. And then cotangent is the reciprocal of tangent. In this case, I'm going to flip my original because then it's just the negative square root of 3 over 1. If you flip this one, you would essentially have to rationalize again, and we don't really want to do that. So there is another example from yesterday. All right, sometimes we're asked what quadrant things are in, and it'll tell us like sine is positive and cosine is negative. So where are you? Stuff like that. So here's kind of a little saying to help you remember. The saying is all students take calc. Okay, now to Miss Marshall and I, this is a very positive thing. Students taking calculus. What that means is in the first quadrant, all trig functions are positive. So all things, sine's positive, cosine's positive, tangent's positive. We're going to stick with just those three, the cosecant and cotangent and those other ones, those just follow because you're flipping them over. In the second quadrant, S, students goes with sine. So your sine function is positive, the other ones are negative. In this quadrant, take, so T or tangent, I'm gonna write sine here, I know I said it, but tangent is positive. And in this last one then, calc is cosine, and cosine's positive. So which means if I say, where is tangent less than 0, and cosine is less than 0, so those are both negative, so that would have to be the second quadrant, because sine's the only thing positive there, and those, so those are true negative. So again, this all students take calc help you remember where things are positive. So everything, all three are positive in the first quadrant. Sine is the only one positive here, tangent here, and cosine here. And the reason, just to show you for sine, this would be a negative number, a positive number, and a positive. Sine is opposite over hypotenuse, and so that one is positive. All the other ones contain the adjacent side. So by other ones, I mean tangent and cosine. So those would be negative. Okay. All right, the one angles that people struggle with, and this is the one that we're going to kind of have a, I don't know if a shortcut's the right word, but another way for you to think about it is probably better, is something called quadrantals. So quadrantal angles are, I'll say angles whose, so terminal side is what I've been drawing when I get terminals, there we go, side. You know, when I went 330 degrees and I drew that line, that's that terminal side. But when those terminal sides are on an axis. So for example, anything with pi over 2, because pi over 2 is 90 degrees, which is right here, because you open 90 degrees. So anytime you fall on an x or a y axis, those are quadrantals. Okay. In pre-calc, we teach you this with what we call a fake triangle. Fake triangle. Okay. And so what we do there, I'm going to delete this so I don't get too much, is we draw it just short of what we want. Now I'm being quite a bit short so I can get a full picture here. And then, so we're saying here, this angle right here is really 90 degrees. And so we just recognize that really it's vertical, but I'm drawing it short so that I can see and draw a triangle. And so what happens then is, since this really is vertical, this side is 0. This side goes up 1, and then by Pythagorean theorem, my hypotenuse is 1. Okay, so again, you will get 1 when you're drawing these fake triangles. They're fake because one of your sides is really 0 because this line actually goes vertical. And so from that picture, then I could say, all right, well, what's sine of x? Well, sine is opposite over hypotenuse, so that's 1. What is cosine? Well, cosine is adjacent over hypotenuse, so 0 over 1, so 0. What is a tangent right there? Tangent is opposite over adjacent. Well, 1 over 0, well, that's undefined. The only possible answers you can get are positive or negative 1, 0, or undefined. Those are your only ones. Okay. Now, another way to think about it, I'm going to draw another kind of unit circle here, and I'll show this on the next slide as well, is thinking about these as coordinates. So really, this right here is really right here. If I were to do this in terms of a coordinate, this is the coordinate 0, 1, because I went over 0, up 1. Okay, and this is kind of where the unit idea comes in, so that's why there's a 1 there. And so these as coordinates represent cosine and then sine. So the cosine was 0 right here, 0. Sine was 1, which is what you had there. So for example, if I take this point right here, this would be negative 1, 0, because I went left and up and down 0. What that means is that cosine of x equals negative 1, and the sine of x equals 0 at pi. Okay, now the way I kind of remember this is it is alphabetical. I know when we are going through these, we say sine, and then we talk about cosine, because we just naturally do sine first, but your ordered pairs are cosine, sine. So they're alphabetical as you go, all right? So for example, if I want to do cotangent, okay, well that's 1 over tangent. So tangent is opposite over adjacent, so I want adjacent over opposite. And in this case, you know what? I'm going to take a different approach to that. That's a little tricky because you don't have a triangle. So if you're like, what's the opposite? So the other way to think about this is that tangent is sine over cosine. Okay, so cotangent is cosine over sine. And so when I look back here, I want pi. So here I'm at pi. I write my coordinate. I want the cosine number, which is -1. I want the sine number, which is that 0. -1 over 0 is undefined. So cotangent at pi is undefined. Okay. All right, now let's get kind of used to that unit circle again. I'm going to zoom out a little bit here so that we can see the whole page. Whoops, just kidding, wrong one. Zoom entire page. All right, so pretend these all line up nicely. I broke each 90 degrees into 3 parts because those are your special rights. So 30 degrees, 45 degrees, 60 degrees. Now I'm not going to put degrees on here, we need radians, but I write that down for myself and I go, okay, that one's pi over 6, pi over 4, and this one's pi over 3. If you can memorize this first quadrant and you can add, subtract fractions, you could fill this whole thing in. So this would be pi over 6, this would be pi over 4, this would be pi over 3, and then pi over 2, because this is pi over here. And we got 0. Okay. Now I'm going to put those coordinates on that we talked about for our quadrantals. The rest of these, yes, there are like coordinates you could write that goes cosine, sine, alphabetical. I'm going to write that again. Cosine is first, then sine. But you're not going to have that on your AP test. Plus, you're not going to use it tons and tons. You might have to evaluate 2 things, but they have to be a special right triangle. So if you can remember that pi over 4 is 45, you can draw yourself a 45 degree or 45, 90 triangle, and then you can set up your sides as 1, 1, square root's 2, or etc. You can figure those out. Those aren't something that has to be memorized. And in terms of memorizing your quadrantals, I'm going to say you want to memorize those, but you're not going to memorize them in terms of numbers. You're going to memorize them as a point. So this is your point 0, 1. So cosine is 0, sine is 1. This is your point -1, 0. 3 pi over 2. This would be -1, I'm sorry, 0, -1, which means cosine is 0 here, sine is -1. This point is 1, 0, so cosine is 1, sine is 0 at that point. Okay. If you end up in any of these other quadrants, what you're going to do is basically, so pi is like 1, right? 1 pi. And so if you want pi over 6 short of that, well, pi as a version of 1 would be 6 over 6. You're taking away 1/6, so it's just 5 pi over 6. So this one should be 5 pi over 6. Same idea, you're going to take a 4th away from 1, so this is 3 pi over 4. You're going to take a 3rd away from 1, so this is 2 pi over 3. Now going forward, you just add. So I want 1 more 6 to pi, so that is 7 pi over 6. I want 1 more 4th, so I'm going to erase this for a second here because it's in my way. So this is, what was I adding? A 4th. So this is 5 pi over 4. I'm adding a 3rd, so 4 pi over 3. Okay. Now, you're not going to have to draw this unit circle. I will say you generally are in one of these 2 quadrants. Maybe you end up in this quadrant if you get a negative pi over 6, because remember, you can go backwards if you have a negative angle. But oftentimes, you're going to end up here. Okay, and to do this 4th quadrant, we think of this as 2 pi instead, which would be like 8 pi like over 4, for example. So if I want to go back a fourth, this would be 7 pi over 4. If I want to go back a sixth, I would think of this as 12 pi over 6. I take a sixth away, so this is, 11 pi over 6. Again, I want to take away a third. Was a third. This is 6. 2 pi is 6 pi over 3. Taking away a third, this would be 5 pi over 3. Okay, that is a lot of information. Again, this was like a whole chapter in Pre-Calc C, but we just kind of wanted to review and bring that back. Hopefully, now that you're seeing this the second time, it works or makes a little more sense. And again, just to highlight the main, you need your quadrantal points so that you can evaluate sine and cosine, and then you need to be able to essentially replicate your 3 special right triangles in any quadrant. But if you can do it in the first quadrant, you just get some negative numbers in other quadrants, so it's relatively the same, just with some negative numbers. All right, let's use this a couple times here and get some more examples. So this says you have a point -2, -7 on the terminal side of angle theta. So I'm going to graph -2, -7. And so that's your point P on your terminal side. I'm going to label what I just did, -7, and then your theta is that angle that gets you all the way to there. So you don't know your reference angle, and actually it's not going to be a special right because you have 2 and 7. But that's why it's in the third quadrant, because they're both negative for that. So if I'm doing my 6 trig functions, that's sine, that's cosine, and then we'll get the other ones as well, which means sine would be -7 over hypotenuse, and then you notice you don't have that. So, all right, if I know 2 sides, how do I get the third? Well, that's just Pythagorean theorem. So I'd have -² -2 squared. Remember, if you're using a calculator, which I don't want you to do, but make sure you put it in parentheses. So I'd have 49 plus 4. Square root still. So this is the square root of 53. So over 53, this would be -2 over the square root of 53. Tangent then, opposite over adjacent. Now I'm going to write 7/2 because they're both negative, so they'll cancel. And then when you do your other ones, so cosecant, you just flip them over. So -53 over 7. Secant goes with cosine, so square root of 53 over 2. I'm going to put my negative up front. And then cotangent is 2/7. So some Pythagorean theorem will show up. Hopefully that's not too much of a challenge as you go forward. All right, let's do some more angle stuff of where these are and throwing in some of your co-functions, so cosecant and cotangent there. So 3 pi over 4. Okay. So here's kind of how I thought process through these. If you want to try this and then watch, like pause the video right now, try them, and then come back and listen to my explanation, that would be a good thing to do just to kind of give yourself that practice and that check. So what I do is I go, all right, 3 pi over 4, I am a fourth short of 1, which means I would be right here. And this angle would be pi over 4. Okay, pi over 4 means this is a 45, 45, 90, which means this side is -1, 1, and the square root of 2. Okay, now cosecant, my brain thinks in the normal, so I think, okay, cosecant goes with sine. Sine is opposite over hypotenuse, and I'm going to just flip that over. So I have the square root of 2 over 1. So square root of 2 would be my cosecant, because cosine would be 1 over the square root of 2. So this is 1 over the square root of 2. So then just flip it over for your cosecant. All right, next one. I have a negative angle. So I'm thinking backwards now, so I'm opening backwards. I'm still a little short of 1, which means I would be here though, because I'm opening backwards with the negative, and I am pi over 3 short. Sorry, my right triangle. So pi over 3, this would be a 60-degree angle, which makes this -1, negative square root of 3, and 2. Then I want tangent, which would be opposite over adjacent. So square root of 3 over 1, well, negative, so over -1, which would just be the square root of 3. All right, now I got negative 3 pi. Okay, so I'm like, wait a second. 2 pi is all the way around. So 2 of the pi is like just getting you back here. Oops, I should go backwards. So since it's negative, I would go, all right, there's 2 pi. And then I would have a negative pi left. And so negative pi brings me to here. So I have, kind of translating this, it's going to be the same thing as the cosine of pi because I'm still at 180 degrees. All right, now this is a quadrantal, so I'm like, okay, either I can draw a fake triangle or I can write my coordinate, negative 1, 0, and then I can think, okay, which part is cosine? Well, it's alphabetical, so cosine is first, so that's just negative 1. Next one, kind of the same issue that you're going to spin a couple times here. So if I have 19 pi over 6, you know, I can break it up into 6 pi over 6. I'd have another 6 pi over 6. So there's 2 pi that's gone. I would have another one over 6, and then I'd have pi over 6 left. And so really these two pieces, like this just gets you back to the original. So I'm at 7 pi over 6. So 7 pi over 6 is a little past 1 pi. So I would be right here. My reference angle would be just pi over 6 because that's how far I'm past 1. That is 30 degrees. So this is negative 1, negative square root of 3, 2. And then cotangent would be that reciprocal of tangent. So tangent's negative 1 over, let me write it out, tangent is negative 1 over negative square root of 3, which means cotangent is just the square root of 3 for that one. Okay, you're not going to have tons of this extra movement going on because a lot of our use of this is going to be application based, and you're not really spinning around stuff. So you'll have like triangles and angles and things changing, but you're really not going to spin a whole bunch. So if this part was a little more confusing, don't worry about it. This part hopefully was straightforward. Okay, then we just have, so part of chapter 5 we were supposed to do in pre-calc C, but with the distance learning we did not do it. And it has a bunch of what's called trig identities. So different ways trig functions relate to each other. And we would use those in kind of like trig proofs, we call them. Like right now you are doing algebra proofs. With working out how these things relate, or with your DEs, like substituting in y prime. Usually in chapter 5 of pre-calc C, we do a similar process, but we have a bunch of trig stuff, that's why we call them trig proofs, where we show two sides are equal to each other by substituting in some of these identities. Okay, now at the AP Calc level, on AP tests, this is the only one that has shown up in our 5.5, going on 6 years of teaching calc. So we cannot say with 100% certainty that nothing else would show up, but we are feeling pretty confident that if it did, it would be a very minor step that maybe you could just kind of figure out. But this one might show up. And so by this one, what I mean is that if you have cosine squared plus sine squared, and that will equal 1, or sine squared plus cosine squared, read it the way I wrote it here, equals 1. All right, now this can be adapted. So maybe you had 1 minus sine squared in an equation, and then all of a sudden you go to look at your multiple choice answers. We'll say this equals x. And then all of a sudden one of your multiple choice is, oh, it's cosine squared of theta. And then B is some other random, and C and D are some random things. And you're like, well, this answer doesn't show up anywhere when I solved it. That is because they use, it's called the Pythagorean identity. So it's kind of a Pythagorean theorem. Sine squared, cosine squared equals 1 squared, but that doesn't need it there. And so there's that substitution. So we tell you this because we know it could show up. It doesn't every year. We're going to give it to you so that you are prepared if it does. And you know, maybe you can kind of be like, oh yeah, they told us that. Otherwise, you know, we shoot for 50% right on our AP test, and maybe this would be one where you get to hear and then you just take your best guess and hope for the best on some of the other ones. So that is kind of our end of our trig. So you've got that trig packet that you got yesterday in class. Now you can kind of do a little more. We reviewed some of the stuff from day one. We added a little more today. So you can kind of keep going with that to get a basic trig review. Tomorrow or your next class, you are going to be learning about section 2.8 and 2.8 in your book there is basically trig, oh I'm sorry, it's 2.7 is trig derivatives. So what's the derivative of sine, what's the derivative of cosine? And just to kind of preview some of the ways that you're going to be using what we just talked about is you might get that, you know, y prime equals the sine of x. And you want to find where y, say y, has a max or a min. And so conceptually in calculus, we say, oh, that's where your derivative equals 0. And so you set your derivative equal to 0. Well, now you're solving this. And so that's where this whole quadrantal comes into play. And if I write those coordinates out, and you're going to be writing these quite a bit. I would just write them on the top of your paper for this assignment. And that's a -1. And so I go, all right, where does sine equal 0? And I remember it goes cosine, sine, in alphabetical. So sine is your second coordinate. So sine of x equals 0 at x equals right here. So that would be 0. Or you could write 2 pi depending on the interval. It's 1 here. It's 0 again there. So pi. And here it's -1 most of the time. So this would be your answer. Okay. They might also give you ones that aren't necessarily quadrantals where you're like, all right, I want to know where sine of x equals 1/2. Okay, so now this is where those special right come in. It's sine, so this is opposite, this is hypotenuse. It's positive, so it could be in either of these quadrants, but when they're both positive, I would probably stick with your first quadrant, unless there's more information given. So my opposite is 1, this is 2, so that means this has to be the square root of 3 to get a special right. And so this has to be 30, but my answer can't be 30 degrees, it has to be in radians. So it would be pi over 6. So where does the sine of x equal 1/2? It would be at pi over 6. And so this is kind of how what we just talked about is going to come into play in section 2.7, which you have, I'll say, your next class, because I don't know when that will be.